Did we all enjoy the rain yesterday? We got a little bit, just enough, and it's nice and sunshiny today. That's the way I like my rains, followed by sunshine, right? Followed by sunshine. Okay, well, welcome to class, everybody. We are going to talk about, so we're going to start to talk about solving exponential and logarithmic equations. So let's go ahead and get moving through these. We are, like I said, we're probably looking at about a week from Monday as being the test. We will probably do some of our Pi Day celebrating next week, okay, rather than after Pi Day. So we are going to go through, and we're going to be hitting these I can statements for this lesson. There's a lot packed into this particular lesson, and I tried to give you more space to write those. I know mine didn't fill the whole thing, but I know some of us have bigger handwriting. How do you solve an exponential and logarithmic equations? And we're going to be able to do these 5 things. So this is kind of like a checklist, right? You have to be able to tell yourself, can I solve an exponential equation? Great, I'm going to get that question right on the test, right? Can I solve a logarithmic equation with a log on both sides? Great, I'm going to check that off. I can do that, right? Because you already know which questions I'm going to ask. They're going to relate right back to these I can statements. I can solve a logarithmic equation with 2 logs on one side of the equation. Great, check that off, okay? I can solve a logarithmic equation with a log on one side where I have to convert to the exponential form with the log loop, which we learned the other day. Great, check that off. And then I can solve a logarithmic equation with a natural log. And again, you want to be able to check all of these off the list that you can understand how to do these, because look at that, that's 5 questions on the test right there, okay? You're gonna see every single one of those when we take the test in a little over a week. And now this computer is dying. I did one of those things where my mouse wasn't working, right? So because I have the plug-in virtual mouse, and I'm like, okay, maybe I need to restart my computer. And I made the mistake of restarting the computer at like 9:08. And guess what happened? Updates. I'm like, oh, great. And then the battery is going to die, right? Okay. So some things that we did talk about yesterday, I think. Yesterday, maybe the day before. So we have these one-to-one properties, and we saw this one actually here in terms of logs. We've seen this one before. If I have a log base A or log base A, or if it's a natural log, or if it's just common log, as long as the base is the same, we know that these basically, we said, hey, these guys cancel, and we get the whatever's inside those logarithms equal. It's one way that we can get what's the variable that's inside a logarithm to be able to solve the variable. We also have seen this one here before too, where if my bases are the same, bases basically cancel, and I just get the exponents, okay? We also saw these inverse properties. We talked a little bit about these yesterday, that if we said that, hey, they equal 1, okay, or just the x that was here, but we're going to put it with an equal sign today. So if I have log base A of A, I know that those cancel and I just get whatever's inside. And same thing with, A to the log base A of x, and then log base A of A, again, they cancel and you get whatever is the exponent. Okay, and we'll see some of those things today. So right now we've got good old exponential equations. And when I approach an exponential equation, the first thing I try to do is try to get my bases to be the same. So same base, same level. That's what I try to go for. Same base, same level. And we did see a little bit of that in Unit 7. Okay, we saw a little bit of that within our last kind of set of stuff. So I see a base of 2. Is there another name I could give 32 as a base of 2? Can you tell me that in the chat, please? What's another name for 2 as a base of 2? What's another name for 2 as a base of 2? Or sorry, 32 as a base of 2. What do you guys think? Can I write it as 2 to some power? All right, looks like we've got 2 to the 5th for most people here. I swear my contacts are getting worse, and I swear I just got the prescription. All right, now we know this and this cancel. Okay, so I get that x equals 5. Done. Easy peasy, right? Okay, let's look at example 2. Okay, technically, I want this on the same level. So technically, in the denominator here, what's my exponent that's on the 3? Can you guys tell me the exponent, even though it's invisible right now? What's the exponent that's on the 3? Excellent work, everybody. Okay, so we've got a 1. I want to bring it upstairs because I need to get this on the same level. So what do I need to do to that 1 to bring it upstairs? Can you tell me in the chat? What do I need to do to that 1 to bring it upstairs? I got one person. I'm going to see if anybody else. Okay, good. All right, good. We got to make it negative, right? So to bring it upstairs, I'm going to go 3 to the -1 to the x equals 9. Well, when we have a power to a power, we know we multiply the exponent. So I get 3 to the -x. How should I rewrite the 9? Tell me, everybody. I want to hear from everybody this time. How should I rewrite the 9? Everybody should be able to tell me that one. How do we rewrite that 9? Ah, nice job. 3 squared. Okay. What happens next? Tell me what happens next. I like that Mariana used the word bases in there, but you all have the right idea, right? And Matthew is getting, I think Matthew might just have a typo. Okay. There you go. Good job, Matthew. You fixed it. Good job. Okay.
I was showing my steps.
Good job showing your steps. Nice work, dude. Okay. So, technically, we shouldn't say cancel, right? But that's what our brains go to is canceling. What we're doing is we're using the one-to-one property. Okay. So if you we'll go ahead and use cancel for Ballard lingo in my class. But if we've got to go to anyone else's class, it's the one-to-one property. We're going to divide by that negative, so we get x equals -2. Okay. I think that maybe we've got so Matthew, you had a little bit of a mistake in your numbers. Same with you, Manuel. A little bit of mistake.
I accidentally hit 3 instead of 2.
No worries. I just want to make sure you were clear. Okay. Let's keep going. So every one of these problems is going to act a little differently. 1 and 2 were fairly similar in the fact that we had exponentials and we could figure out very easily how we could get our bases the same. But what happens if we can't do that? Okay. So when we have 1 log on one side, we're going to condense. So I just said 1 log on one side equals condense. So what we were learning yesterday, we talked about during our 20 minutes together yesterday. So we've got something to condense together, and it doesn't matter if it's log or natural log or log base, whatever, right? It could be log base smiley face. It wouldn't matter. When I see subtraction, what do I have to turn it into? Can you guys tell me that? When I see subtraction, what do we turn it into? I think you guys were ready for me to say that, huh? Were we playing the game Anticipate Mrs. Ballard's question? All right, I got to turn that into division. So we've got the natural log of x divided by 3 equals 0. All right, we're going to learn a fancy name now for something, okay? Technically, what we would do next is the log loop. But when we see a natural log, we have another thing that we are allowed to do, okay? So the fancy word that we're going to learn is called exponentiate. Try to say it like 5 times fast. You're the only one in your room, right? So you can say it to yourself 5 times fast. Exponentiate, 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 exponentiate. Okay. So it's a very fancy word for saying that we're going to, because we know that e and natural log go well together and they will cancel each other out. Okay. Basically, we get this going on here. If I've got natural log of e to the x, it equals x, right? They cancel. Or if I get e to the natural log of x, they cancel, okay? But we have to create that in this problem. So whatever I do to the left side of the problem, I have to do to the right side of the problem. Those are our algebra rules, right? When I can't just do it to one side. So I know the way I get rid of natural log is by doing e to this power. And we call that process exponentiating. Okay. We use natural log a lot in the next course. Okay, so we use it a lot in calculus. It's like, actually my calc kids are coming up on the unit where I'm going to use it a lot right now. So in about a year, you're going to be seeing this come up a lot. Okay. All right, so hopefully you can remember the fancy word. You'll impress me if you remember the fancy word. Okay. All right. So these guys are going to cancel now. So that's the process of exponentiating. So I've got x over 3 equals e to the 0. What's e to the 0 equal to? Or anything to the 0 power e equal to? Tell me in the chat. What do you guys remember? All right, nice job. It is equal to 1, okay? It's not equal to 0. It's equal to 1 because there's only one way I can get e to the 0 power. It's 1, okay? All right, so I'm going to rewrite that as 1. So we get x over 3 equals 1. And then I'm going to go ahead back to my like pre-algebra algebra rules, and I'm going to multiply both sides by 3. So I get that x equals 3. I want to check, because I had logarithms, to make sure if I plug this into there that I'm not going to get a negative inside the log. And as long as I don't get a negative inside the log, x equals 3 is a good answer. Okay? All right, I'm going to pause for about 30 seconds. Make sure you've got it all written down. And our fancy word is exponentiate. Okay? That's like our $1 million word for the day, right? All right, let's take a look at example 4, okay? So on example 4, I have one log on one side, it's already condensed. So there's two things I could do. I could do the log loop if I have a common log, or I could exponentiate it if I have a natural log. So which one am I going to do? Am I going to do the log loop, or am I going to exponentiate? Tell me, what do you think in the chat? Some of us even spelled it right. I honestly don't know if that's how you spell it, but that is, I think I'm close. Good job. We're going to do we're going to exponentiate both sides. And again, it's the process of getting to that x that's trapped inside that log, okay? The only way to do it is to exponentiate. So e to the natural log of x equals e cubed, okay? The word, thank you, Cole, okay? Exponentiate, okay? All right, we're going to cancel the e and the natural log, so we get x equals e cubed. E cubed is a perfectly acceptable answer. You're going to start seeing that because we'd rather see that as an exact value than a decimal point. Okay, a decimal point is an approximated value, whereas if they ask for exact value, they want like e cubed. Sine of 0. They have something with a pi in it, pi over 4. Okay, because we're going to start seeing that word exact value a little bit more. All right. So looking at example 5, we have how many? Well, tell me in the chat. How many logs do you see in the problem? Do I have 1 log, 2 logs, 3 logs? How many logs do you see in the problem on example 5? All right, 1 log. So that means I have natural logs that exponentiate. If I have regular log, common log, or a log with a base, I do log loop. So what am I going to use? Am I going to exponentiate, or am I going to log loop? Tell me in the chat. And I know log loop is Mrs. Ballard's words for it, but we're going to go with that as our communication tool. All right, we're going to log loop it. Can you guys tell me what is the base I'm working with? What base am I working with here? Good job. Nice work, everybody. Log base 10. Okay, and then I'm going to loop this around. So what's going to become the exponent on this? Can you guys tell me what's the exponent? Nice work, -1. And it's going to be the x on that side. Now, likely that would not be our answer choice, right? We're not likely going to see a negative exponent, okay? So remember, there's always a like 1 in the numerator with it. I'm going to bring this whole thing downstairs. So I'm going to keep a 1 in the numerator. I would do 10 to the first, or just 10. So it could just look like 1/10. And again, I forgot to test it on the last one, but I do want to just quickly verify, hey, there, it's not going to make it negative inside, so we're good to go. Okay. All right. Look at example 6 and 7. Notice they're just expressions. They're not, there's no equal sign this time. Okay. What do we know about E and natural log when they're next to each other like that? What happens with E and natural log? What do you guys think? Oh, we're going to get to cancel them out. So you mean all I have to do is this, and I just get 4x plus 1? I think we need like half the test to be that, right? It won't be, but that would be nice, wouldn't it? Okay. Look at this one here. It's e to the natural log. Check it out. It cancels out too. X to the 4th. Lauren wants me to put half the test as those. So wouldn't that be nice? All right. I don't know, you guys. I'm kind of tired of taking notes. Are you all tired of taking notes? It's 9:37. Javier says he's tired. Yeah. Yeah, I think we need a break from taking notes. Don't you think we need a break from taking notes? We've been doing notes. You guys have been very good. All right. And since you guys have been so good and you guys' grades have been so good overall as a group, I think instead of finishing notes today, I think we should play Kahoot. What do you guys think? Should we play Kahoot instead of taking notes? All right. It's going to be Kahoot about logarithms, but it's Kahoot. Okay. All right. So you guys ready? Go to kahoot.it. Miguel says he prefers notes. I hope you were joking. So we will play.
Well, it looks like someone's bad at Kahoot.
You're dead serious. Okay. All right. Well, Miguel, I'm sorry, but we're going to play Kahoot. So everybody go to kahoot.it. You all know how to get there, right? You just type in, you can split your browser screen. You can do this on your phone. If you've got a smartphone, go to kahoot.it. Let me switch over to a different